Alright, we are finally moving on to a new target here. This is 7C, and this is interpreting systems. Alright, so systems with no solution. Hopefully you figured this out by now, that if you graph them, the lines do not touch. Alright, and systems with infinite solutions, when you graph them, actually end up being the same line. So if you look here, this one and this one, if you were to put them in slope-intercept form, would actually come out to be the same equation because they're constantly touching. Alright, so now the question that appeared on your quiz and will appear on your test is, why is the solution to a system of equations a linear pair? And that's because the two lines will cross at one point. So this point where they cross is a point on, a graph, and so that's why it's a linear pair. Alright, so your first couple examples are, you're going to be given one linear equation and must create another linear equation that either makes a system have no solutions and infinite solutions. So take example like this is basically how it's going to be set up. You'll be given one equation and you're going to have to come up with an A, B, and C that either creates a situation where there's no solutions or infinite solutions. Alright, so here's how you create your second equation. You determine what the A, B, and C are of the first equation, and then you can find more solutions by multiplying the entire equation by 2 or 3 or whatever. So if you double or triple it, you've got to just make sure you double or triple everything in the equation. So for a system with infinitely many solutions, that's pretty much it. For a system with no solutions, you just want to change your C value to any other number. So that would be the one case where you multiply your A and B values by the same thing, but then C, you just change it to any number. Alright, so let's take a look at this. In example 1, we have to give two sets of values for A, B, and C to create a system with infinitely many solutions. Okay, and for the second one, we have to give two sets of values for A, B, and C to create a system with no solution. So let's start off with this one. We're going to double the values. Okay, so we've got a value of 2, 1, and 8. Okay, so A is 2, B is 1, C is 8. So if we double each one of those, we'd get 4, 2, and 16. Alright? If we tripled everything, we'd get 6, 3, and 24. Alright, so now if we were to, and that would be for doubled and tripled. For coming up with no solutions, you can basically do the same thing, just change this last number. So 4, 2, and instead of 16, let's just pick 10. Okay? For the second one, 6, 3, and we can just make that 17. But see how like that and that are the same, that and that are the same. It's just that these two are different. Okay, and all you're doing is multiplying each one of these by 2 and then 3. Okay, so why does this work? Because if we were to put those equations in slope-intercept form, that would give us the exact same line. Okay. For the second one, it works because what it would do is create a bunch of parallel lines. They would all have the same slope, but their y-intercepts would be different, as you can see here. So same slope, same slope, same slope, all different y-intercepts. Alright, so let's try it again. This time I'd like you to kind of pause it and see if you can come up with it. I'll give you this, though, that A is 3, B is 1, and C is 17. So see how we've got 3. Remember, there's a 1 there if there's nothing there, and 17. So that's how we get these numbers. Alright, so go through and go ahead and do that. So if you doubled everything, you should have gotten 6, 2, and 34. And if you tripled everything, you should have gotten 9, 3, and 51. So basically all you're doing is multiplying each one of these by 2, and then each one of these by 3 to create infinitely many. And then we're going to take those same two first numbers and just change the last one. So 6, 2, and negative 6, and then 9, 3, and 30. So you kind of have an idea as to how to do this. For no solutions, all you're doing is changing this last number from this one here. Everything else remains the same. Your second set of examples that you're going to have, you're going to be given a word problem to solve, and you must interpret the meaning of the solution. Alright, so what does this mean basically? Okay, so each system, there's going to be two different strategies you're going to apply here. One, where you have it in kind of like a slope-intercept form. Okay, there are always two rates of change in the initial conditions, and two initial conditions or amounts that you start with, so they give you this kind of y-intercept here. And in that case, since these both equal y, just set them equal to each other on either side of the equal sign. Standard, and this is ones where you're going to have to kind of like, you'll be able to see the equations and see a pattern in it. But this one we solve by elimination because it's in this form right here. And again, solve it using elimination. So in this example, we have two recording studio cost functions. Now if you have a cost function, that's going to clue you into something here. So one has a $250 production fee and 45 cents per song download. The other one has a $125 production fee and 65 cents per song download. Alright, so this is the initial cost, or your y-intercept. And this right here, these are what gets a variable, as you can see by that per there. Alright, so that cost, that total cost, is C, and that's kind of like your y. So imagine that that's your y, and the S is the x. So these are in slope-intercept form, so we're just going to set them equal to each other because they both have C. And then it's just a matter of moving things from one side to the other. So start off by subtracting 0.45s from both sides. Okay, and then that'll give you 250 equals 0.2s plus 125, and then subtract 125 from both sides. You get 125 equals 0.2s, so divide everything by 0.2, and you get s equals 625. And then you go ahead and plug that into either equation, it doesn't matter which, to find c, because c is the same for both, and you get c equals $531.25. Okay, so that means that at both recording studios, the cost is this number, $531.25, when you download this many songs. So in other words, if we were to graph this, this would be the point where those two lines would cross. Okay, this one's going to take a different approach. You have an army of orcs and goblins. Orcs are X, goblins are Y. So that, again, should clue you in that you're going to be using elimination when they tell you what the X and Y variables stand for. As far as they represent two separate things and there's no total cost involved. So for breakfast, orcs eat 4 pieces of maggot bread. Goblins eat 3 pieces. Army eats 265 total. Weapons, orcs have 3. Goblins have 2. Army has 190 total. So we want to find out how many orcs and goblins there are in the army. So in this case, we already have totals. Okay, this 190 total. Okay, 265 total. That's, it should tell you right off the bat that whereas in the other one our cost was our unknown, now we know what that kind of figure is. So we would solve this by elimination. So I'm going to go ahead and solve for the y. So I'm going to multiply the top by -2 and the bottom by 3. Because remember, you're taking the top, or the top multiplying it by the bottom, and the bottom multiplying it by the top. And because these both have the same sign, I have to make one of those negative. Alright? So now I'm going to multiply each part by -2. So I get -8x minus 6y equals -530. And then on the bottom, I'll multiply each thing by 3. So we get 9x plus 6y equals 570. And then go ahead and add in columns here. These cancel out because I was trying to get rid of my y's. So I end up with x, because this is just 1x, so that becomes x equals 40, because -530 and 570 equals 40. And since x was orcs, I know that that's how many orcs there are. So I go ahead and plug that into either equation, like we've done. I know how much you guys love elimination. So I'll plug it into the top one. 4 times 40 is 160, plus 3y equals 265. Subtract 160 from both sides. You get 3y equals 105. Divide everything by 3, and you get y equals 35. So there are 40 orcs and 35 goblins in the army. Alright, some tips. When you're writing equations that have either no solution or infinitely many solutions, make sure you know the conditions of each. Meaning infinitely many, everything is getting multiplied by the same number. And with no solution, only the first two are basically getting multiplied by the same number, and just change the last number to anything. And then when solving real world problems involving systems, make sure that you know which method is going to work best in which situation. So set them equal to each other when you have something where you're trying to find a total cost, for example, and then use elimination when you're kind of given like what the x and y variables would be. All right, that is it.